sucking the paper up in a sense.
With this one, I can actually turn him a little bit, about 45 degrees almost, and the ball will actually continue to levitate.
So, does anybody know why when he holds it up, right? So holding it straight up, that makes sense, right? Common sense tells you that when you have this high-speed air underneath the ball, it'll float. But how come when I turn it, the ball stays in this little stream of air? You notice that? There's no wires there. That's all just air pressure.
Also, a lower pressure region above the ball that's holding it up, which you can disrupt. So, you see the ball floating here, and if I hold my hand above it, I'm disrupting the low pressure above it, and the ball's actually sinking, like that. And then when I let it equalize again, it comes back up. So this is a low pressure region, lower pressure even than this column, and it's sucking the ball up as well, so I can disrupt that. The ball starts freaking out.
The other thing you can actually do as well is,
Thank you.
you can introduce a second ball into it. It doesn't work as well as we wish it did.
They fight for a little while, and then one kind of kicks the other one out. But
Because of how narrow the actual the channel of air is, it only has so much room to compensate for a single ping pong ball. So if you have this one floating, and try and introduce the second one,
that's actually cool. Like
they're going to fight over the actual airspace that they have until that one is out, and again, it is able to equalize once that happens.
Air fluid has lower pressure, than low speed air. And then true or false? Ping pong ball stays in place because the high speed air has higher pressure than the atmosphere. False. The high speed air has lower pressure. And you guys all learned the Bernoulli principle.